All right. Welcome to this second day of the Software Craftsmanship Barcelona conference 2018. Hope you all had some coffee already. This talk is called Reactive Microsystems because the actual title was too long to fit on the schedule. The actual talk is boring slide decks with lots of boxes and caffeine deprivation don't go together. They knew this, so that's why probably I got this slot. Compulsory slide for the sponsors. Thank you all for making this possible. Who am I? I'm Ignasi, I work for Legume. I'm currently on the Play Legume team. We just merged. Play is a rapid web development framework. Legume is a microservices framework. But that's not the topic today. The topic today is to talk about the monolith and what we refer to as the microlith, and by we I mean Legume and some other people start picking up, or other people started that and then we picked up. I don't know who started that. And hopefully we'll have time to get into microsystems. But first I found out that it was good to add a few disambiguations. Reactive. Oh, that's a spoiler. Okay, let's imagine that that isn't there. When I use reactive on this talk, except in a couple of cases, I refer to a reactive architecture, a reactive system, something that spans your process. I'm not talking about reactive extensions or React or stuff like that, okay? It's not the same reacting programming than reactive systems. This talk is more about the system itself, except in a couple of occasions. I used italics on this couple of occasions. There's more on Reactive Manifesto. To make this talk compliant for Software Craftsmanship Barcelona, I added an emoji. It's here. The other detail, just in case, because it's also a source of confusion over and over and over. It's not the same thing, message passing, than event-driven or event passing, okay? Message passing is a building block. Event-driven is a feature, sort of, okay? The main difference is that when you're passing a message, when you're sending a message, you know where you want it to go. When you're emitting an event, you can only know where it comes from, right? So when we talk about events, we talk about addressable sources. When we talk about message, we talk about addressable recipients, okay? All right, let's get to the meat of it. Compulsory story about the monolith. Like I said, use a lot, and I mean a lot, of boxes. They all look quite the same. This is the monolith. It's a big box with small services, responsibilities. It has an orange database, which is the source of truth, and it has a blue database, which is some denormalized data, maybe some cache, okay? The color coding is relevant here. And we want to go into something, or we used to, or as the first step, as we were learning about microservices, split this monolith into smaller pieces that would interact with each other through REST calls, right? This has some problems, blah, blah, but most commonly, these smaller pieces were still 3 layers, were still maybe some other architecture, but we're still using this exact same approach of programming inside the process, I mean, like we would on the monolith. It would have the same problems when scaling. Okay, I have a lot less features per box here, but I will have the exact same problems when I try to scale, okay? This talk is about scalability, it's not about other stuff. And we said, okay, that's good enough. I have now 5 teams they can deploy on their own pace. They document their APIs so we can communicate services, but this has some problems. I can use polyglot programming, so each service is using a different technology, a different framework, but I've got spatial, I broke the spatial coupling, but I still don't have failure containment, meaning if a request arrived, hold on a second. Oh, come on. If a request arrives here and it needs a call here, and this one is down, my request here will fail, most probably. Or if the one downstream is lagging behind, it's on a huge load, it will impact me. I don't want that, okay? So we said, okay, let's try to use a different approach. Instead of use synchronous calls, I used event-driven or message passing. Okay, let's not get into that discussion now. Okay, I no longer use REST calls across my services. Maybe sometimes I do, okay, but now I have a broker. This is a lot better, okay? I've got temporal decoupling. When one is down, I just don't care. I don't go fetch the information. I already have the information, okay? I didn't want to bloat this graph here, but probably I will have some stale copies on my service so that when I need some information, I don't need to go fetch it, okay? One of the drawbacks of this approach is I will have eventual consistency probably, okay? But maybe not a drawback. That's how the world works. But are these microliths either reactive microliths? We don't care how they are programmed at the moment, okay? We've done a refactor of our monolith at an application level, at a high level. We still haven't peeked into the process, okay? What are reactive microsystems? Before we dive into what are reactive microsystems, this is a blue panther butterfly. I wanted to add this to make sure that everyone's still awake. Everyone's still awake. So microsystems is what we aim to get when we need to refactor our microlith, reactive or not, with resilience and scalability in mind. Again, we split the monolith because we have several teams, but there's this team that is getting hit a gazillion times per second. They need to do something that really scales well, hundreds, thousands, I don't care, lots of instances, okay? So we've seen the high-level transformation, but we still assume maybe that each of the services is a microlith. It's the exact same approach that we used to develop like 10 years ago, maybe. Okay, it's a Spring Boot 3-layer. That is a perfect solution for several problems, but not for the problem that we're trying to solve today, which is high scalability. So let's focus on this. First thing we can do, for example, and this is a very simple refactor, is try to use different models for read and write. That won't get us very far, but it will force our mind to start to shift. Not all teams have gone through this process, and it's an interesting exercise. It's not compulsory at all, but it's worth, it's a step, in my opinion, small enough to put this in place. You have different models, or they can be even the same modeling, but separate interfaces, which later will allow us to use different implementation, even if it's the same modeling. It's not too important, the modeling at this moment for me, okay? Once we have this, for example, we could do that, which is every time we write, we still maintain the same source of truth, we still maintain the exact same database schema, but we start writing a complementary log of events. Every time we write, every time there is a change on our state, we store this increment on an append-only journal. I'm not talking about Kafka, I'm not talking about brokering, I'm not talking about anything like that. It's just a very simple table on your database where you just append rows. It's as simple as that, okay? Still, the event journal is not the source of truth, but it helps us continually shift the way we think about our state changes, about our system, okay? But there is a different path to get there, which is, okay, I don't split the reads and writes, and I just go straight ahead, and all my bloated repository layer services, I don't know the name that you use, creates a complementary log. Okay? The important thing here for me is the complementary log at the moment. Okay? I start denormalizing my data with the purpose of having a complete history of changes. This is append-only log of changes. Show of hands, everyone who is familiar with an append-only event log for your database? Anyone who has used it in production sometime? Okay. Now, compulsory poll. Do you want me to go a bit into detail about that? Should I move forward? Because the log of events is a key piece of the puzzle. Okay. A journal of events, or event journal, or log, there are several names for the thing, means you no longer store a myriad of tables to persist your state. You have a single table where you keep storing everything that happened. And the most common example for that is your bank account. In your bank account, you have one row that says you have €0. Then you have one row that says you deposit €10. And next to it, you have the current state, which is €10. Then you deposit, you get your monthly salary, blah, blah, blah. And every single row is a statement, is an event that alters your current state, which is your the amount of money you have on your credit account. Okay, that is the perfect example. And there are only two events, deposit or withdrawal. Okay? Another example could be, I don't know, a ticketing system for a conference. I have 100 tickets. Someone comes in and buys it. I have 99, buys it, 98, etc. Oh, no, I can't attend. I will cancel my attendance. Shopping basket, Amazon.com. Add item, remove item. I want 3 of these items. All these are events, and the final state is relevant when I check out, but all the steps are also relevant for data analysis, knowing how people change their mind. So that's also very relevant. The idea here is that I no longer have a current snapshot of the world. I have a complete history of how I got here. All right, so let's move forward. Here, my tables are still the source of truth. I'm still not able of reconstructing the current state only with the events. It takes some time, it's a big mind shift. It's not easy to do on brownfield projects. It's easier to do on greenfield projects, of course, but still doable, okay? Because we aim at having our event journal as the source of truth. And we may keep the tables because, after all, we're very familiar with SQL select statements, or we may have these 100,000 lines of code that rely on this. Okay? But the nice thing about that is that the moment that I want to change the database schema, I drag this, and I can reconstruct it from my events. And I can just create a completely different representation. I have everything that happened since the Big Bang of my system recorded. So I can just decide that I want to represent it in a slightly different way, which may be faster, which may be more efficient for my views, whatever. Okay? But still, in this case, both storing the events and both updating my tables happens in a single transaction. Okay? Everything is consistent, everything is nice and shiny. We are happy with consistency, we are happy with transactions, right? That's what we are good at, that's what we've been doing for ages. Here's the last piece of the puzzle. Again, with scalability in mind in all cases. Let's make the propagation of changes and a synchronous operation. And why would we do that? If the event journal is an append-only log, I can know that I have event 1 and 2 and 3 and 4. And I can track, okay, I've consumed up to event 10, up to event 25, so that I can always know what instant in time is my projection representing. Okay, so that's safe, I'm good. I will not consume the same event twice. That's good enough. But the actual advantage is that because these two updates don't happen in the same transaction, and the main transaction, which is storing events here, is just an append operation on a single table that I can fine-tune very well, this becomes a lot faster, right? Next step, get the events on a cross-service broker. But actually, I could already do that here. I already had events here, so I could already do that there. So it's not, we don't have to go all the way to start emitting events. But the nice thing is that I could even do that on the previous one, okay? You don't have to go all the way to start emitting events. But at the same time, you have to be aware of how much amount of the whole truth are the events you're emitting. Meaning, here, I know my events are the whole truth. They are my source of truth. Here, I know my events are the whole truth. They are source of truth. Here, in this track, I know they may not be the whole truth. Meaning, anyone outside my boundary may not be able to reconstruct my state, okay? At the same time, I may decide that there is some data that I do not want to leak to other systems. So I could filter here. I don't have to push all the events, okay? I want to insist here because it's not the same in boundary events and out boundary events, right? Okay, putting this that we've just seen into words. We've seen a CRUD microlith, a microlith that separates write operations from read operations, a complementary event log, an event log as the source of truth but happening on the same transaction than my projections, or an event log as the source of truth with eventually consistent projections. Picture, picture. These are two fishes. Wonderful. So microsystems, okay, we've done a huge recap of things that more or less we've heard about. Again, microsystems are one solution that we've come up with. I'm not saying it's the best solution, I'm not saying it's the only solution. When trying to refactor a reactive microlith, and this is reactive programming, not reactive systems, okay? With scalability and resilience in mind. So we went from this to that, and then at service level, we went from this to that, right? What is the next step? I had a problem here when preparing my slides, so you'll have to bear with me. I had to rotate counterclockwise 90 degrees because labels would not fit. So this drawing here is exactly the same here, right? So before my request would come from top, now my requests come from the left. My right side is now on top when it used to be here. That's clear, right? I apologize about it. Let's step into details for a second. We have some request response coming in here. This is plain old HTTP, JSON, gRPC, RPC, whatever. This is my service layer that produces a state change on the right side, which is stored on the journal and then is projected into, of course, projections, which are eventually read by some other request and then sent out. Okay? But what are that thing up there, snapshots, and what are the orange arrows? The orange arrows is a projector that communicates to the outside and prepares some external API events to be emitted to an inter-process communication channel or broker, whatever. Snapshots are a tweak on event journals so that you can reconstruct the current state faster. Okay? What just happened? What used to be 3 classes inside a single process may as well be different processes. Okay? We don't need to keep all my service as a single deployment unit. I could make several deployment units. After all, if I have a single deployment unit and I want to start 10 copies, they're already 10 deployment units. Oh, but they're the same. Well, but it's 10 boxes that you have to monitor. Are they all 10 all the same? Cannot I specialize them? I want these 2 to continually run projections. They are more powerful. I'm paying a lot of money on Amazon. I want to have some affinity of what's happening on those 2 boxes. Let's make different processes. Or let's make the same binary, which I can tweak on deployment time. Oh, these chairs. So let's imagine that these 11 boxes are the same binary, but on deployment time, they are specialized, right? They all know each other, and they can communicate each other within intra-cluster. Let's imagine that this is a stateful cluster. Okay? I want it to be a stateful cluster. It doesn't have to, but I want it. And this is forcing me to think of my service as a distributed system. This is no longer a small box. It's something that spans the idea of my traditional happiness 3-layer. Okay? But why am I doing that? Because I want to scale. And I want to scale considering that each of the boxes has different responsibilities. An extra detail. I want my state to no longer be part of responsibility, sorry. I want my state to no longer be responsibility of my database. I want my state to be responsibility of the whole thing. Okay? I no longer develop stateless code. I want my code to be stateful. Why would I want that? It's more difficult to think and code a stateful system, right? Anyone had to develop something called a memory image? Okay, I was expecting that. In memory image, in a system that has memory image, you keep all the database in memory, okay? Let's imagine that everything that I have on my journal, all these events, let's forget it's a journal, let's forget it's an event log. Let's just think plain old collection of tables with primary keys and foreign keys and whatever. Let's imagine that every time that I start my process, all the database is put into memory. And every time that I change my memory, I synchronously or asynchronously store the change on the database in case the process dies, right? Why would I want to do that? Because in that case, I no longer have to deal with concurrent edits, right? The moment I have all the state in memory, sorry, let me rephrase. I still have to deal with concurrent edits, but I no longer have to trust this on the database. I can do it myself. I don't longer have to go one extra layer, okay? Why do I have so many boxes here? Because I can also decide that I want this shard of my memory, of my state on this process, this shard of my state on this process, okay? So I can split all my state through my processes. I keep all the state in memory. And because I'm sharding, I know exactly where each piece is living. Okay, let's put an example because we went in a lot deep, okay? Let's imagine we are eBay and Justin Bieber is auctioning a flock of hair, right? Who would try to buy that? I would. Wow, lots of hands. Good audience. Gazillion requests coming in. How do you make sure that all the requests get the appropriate response? Your bid got in, your bid got denied, your bid got in, your bid got in, right? How would you do that? Would you go every single time on the database? You have 10 instances of your service, all requests coming in all the place. Do you go and log the row on your bids table every single time? That will be horrendous, right? What we could do is, okay, let's get the flock of hair state into memory. Let's tell all my front ends the flock of hair auction is happening on this process. Let's allocate a wonderful bandwidth for this process, and let's get requests one at a time. No worries. I don't need to trust the database. I can do it myself. Every single time that I accept a request, I store it and I keep going. I can very easily develop this concurrency protection across my flock of hair in process. I don't need to trust the database anymore, and the database can deal with other problems, right? That's what's happening here. Does that make sense? Yeses, noes, questions? Okay, some questions. That's good. I like that. For example, sorry, hold on a second. There's a mic coming in. There is no mic coming in. Microphone? Anyone? There is a microphone coming in. Thank you, Alvaro. Okay.
The question is, what about the hot shards, for example, because in this case you are redirecting to one of the processes, but you start to having a vertical limit in this sense.
Mm-hmm.
For sure it's a high limit because you can optimize, but how you prepare this bandwidth for this? Because it's the actor model, no? But in this case, you generate a new vertical limit, completely different than the 3 layers limit, but...
Can I troll you a little bit?
Sure.
I'm sorry, maybe I did. Did I say actor model yet?
No.
Okay. Okay, I was trying hard. I was trying really hard to not say actor model. This talk is not about that. Okay, there will always be limits, and I'm not saying that actor model is the best solution for this. There are other concurrency models where you can grant that all the requests will linearize even without locking. Okay, you've got what's the name for that? I forgot. Martin Thompson developed that. It's a ring buffer.
Yes, SAS ring. No?
Come again?
No, it's
well, it's not reactor. What I'm trying to say is that I'm not that worried about how you model, how you implement this concurrency control, but what I'm trying to convey is that this concurrency control is no longer on the database. Mm-hmm. It's in process. In any case, there will always be a limit. There is no infinite CPU. There is no infinite bandwidth. if you are too successful, if 7 billion people want to bid on Justin Bieber's flock of hair, you may have to stop that auction. Yeah, you will have to do that.
Hello. Hi, Ignasi.
Hi, Gonzalo.
I have a question. Why not use, in this case, maybe it doesn't fit in this example, but a distributed database that fixes this problem for you, like, let's say, DynamoDB or something like that?
Mm-hmm. You are pushing the problem to someone else, but the problem still exists. It may be a very valid solution in several scenarios. This is another solution. Okay, what I'm trying to convey, and this is a spoiler about the conclusions. I'm not saying that this is the solution. I'm saying that this is another solution, right? That is an important key, a key takeaway. Yeah.
Okay.
Good
Thank
question.
you.
Thank you. Any other questions?
Hi.
Hi.
So how do you deal in this case with, or maybe I didn't understand that you did explain it, with race condition conflicts, no? If you have two requests that are trying to, you have the classic thing that you do with a constraint in MySQL.
Mm-hmm. The factor here is that I have programming models and libraries that deal with this problem already. I don't need to worry about that. For example, like Eduardo said, the actor model. In the actor model, I have the guarantees that my state is protected in a way that every change will happen one at a time. There is other log-free data structures that also help me build these guarantees. Okay? Moving your state from the database to the process is not a simple step. This talk is not about that. But certainly, it's a problem that you would have to keep in mind. There are actually two problems. First is making sure that you don't have the same state, this Justin Bieber flock of hair, in different instances. So your cluster needs to know all the nodes that are contributing on the cluster and know exactly who has what, with a hashing algorithm, for example, or I don't know, some other algorithm. And in your process, you have to prevent these race conditions. Yes.
Okay, thanks.
Question here? No? Yes? No? Cool. Okay, shameless plug. This is what Legume exactly looks like. And this is quite the mouthful. Legume is a microservices framework promoting the creation of services via contract-first reactive microsystems implemented as small clusters with secure SES persistence layer. End of shameless plug. This is how some of our sample applications or customers look like. This is particularly a sample application. This is an eBay ripoff. It's got a web entry point that is just adapting APIs or presenting HTML. And there is a user service, an item service, a bid service, communicating each other with a Kafka broker. And then there is a search service that will keep an eventually consistent state stored on Elasticsearch, which is a wonderful product for searching. I don't want to implement search over RDBMS inside my items service or Cassandra. I don't care. I can specialize it. Right? Okay, I already talked about that. When I want to scale up my writes because I'm lagging down because I have a particular very successful part of my state, I can just pin it. Okay? Equally, let's talk about projectors. I could do the same here. Projectors will be consuming my intra-process event log. And the way that I can scale these projectors is by adding an extra information on my log. I told you before that the event log is append-only sequence of state changes, okay? Like in the bank account, deposit, deposit, withdrawal, deposit, deposit, withdrawal. But I could, for instance, decide that this third of the room is marked as customers 1, then this middle section is customers 2, and then the last section is customer 3, right? This is not very relevant information for the event log, but I'm helping the projectors distribute the load. Because I created 3 shards on my event log, I can build 3 projectors working in parallel, and I will guarantee that this third is projected sequentially, then this middle third is projected sequentially, and then the last third is also projected sequentially. But altogether, I will lose the guarantee that every single event is projected sequentially. But it's a trade-off, okay? I can now scale how my projections are being created, right? Makes sense? But has a problem. When I want to scale my projectors, I have to go back on the right side and decide that I need not 3 shards, but 10 shards. So it's something that could be improved. It's something that I have to think beforehand. I have to change 2 bits. Actually, to change the projector, I have to change the right side. Does that make sense? All right. So that's a Reactive microsystem. It's still a service. It's got inter-process communication, but because it's not public API and I have full control of how all these boxes are deployed, because it's intra-team that I have to deal with this, I can change and I can make improvements a lot faster. I don't have to maintain a public API. Actually, I have to maintain a public API. There's public API here. It's public API here, but I would have to maintain that anyway. Okay? I can think of stateless and stateful separately. I can have a bit more specialized bits and pieces that I can run. Okay? So the question is, how can I take some of these learnings back into my monolith, which was one of the main purposes of this talk? Okay. You can start separating stateless from stateful and use stateful on some areas that you think would benefit from moving the database back into memory. You can separate reads from writes and use different models so that it presents faster or it persists faster, depending on what's your bottleneck, by means of denormalization or by means of 2 different models, but then paying the price of having some impedance. You can emit state changes with several strategies in transaction, complementary log, log as the source of truth, etc. And of course, deploying your service with specialized nodes. But it will require your services to know each other, your instances of the service to know each other. You will have to also tweak your service location, because you will have to deploy 10 instances, but maybe 2 of them are specialized, so they should not be locatable for other services, if that makes sense, right? And the conclusion, like we were discussing earlier with Gonzalo, in my opinion, it's not about monolith versus microservices. It's about knowing that there are some alternatives. This is a very specialized architecture. It comes at a cost. It requires lots of mind shifts in very particular areas. If you're ever successful, and I hope you are, by successful I mean gazillion requests per second. I don't know if you are already, actually. Maybe you already are. And your system needs a dramatic scale up. Maybe give this a try. Thank you. Any questions? I know I'm on your way to coffee, so I understand if there are many questions.
Okay, I see that is a very specialized high throughput architecture. For example, how do you deal with fault tolerance in the sense that you are making the shard in the boundary, so you need to know the instances. So how do you deal, for example, with dynamic scale up and also for the fault tolerance?
Just to make sure that we're talking about the same thing. You're talking about what to do when one of these dies.
Yeah, yeah. For example, in this case, you already know that you have 10 instances, you have already defined the shards, perhaps one of them you lose this shard, so you have the throughput in the others, but not in this. Can you scale up dynamically or not, or you need to decide, and this is the throughput all day for this until we take another decision and redeploy, for example?
The strategy to shard the memory image is dynamic and is directly communicate to all members of the service. So everyone knows at all times where to find a particular instance. So the Justin Bieber flock of hair would be locatable at any time. If it was in this super beefy machine and that dies, the cluster will rearrange the memory images and start it on another beefy machine. And everyone would be aware of that because everyone knows at every single time who is contributing on the cluster. And because I have this collection of nodes and I have the hashing algorithm, given the ID of the Justin Bieber flock of hair, I can hash and locate the particular node at every single time.
So you have protocols all the time to be dealing with this sharding, with rebalance if needed.
Yes. So, well, rebalance comes for free. It's a hashing modulo number of nodes, right? The only key piece is everyone must know who is contributing on the cluster at every single time.
And is the framework, or are you using any protocol for?
In this particular case, it's based on Akka cluster.
Okay. Yeah. Thank you.
Akka cluster, by the way, is a particular piece of the Akka toolbox, which is also maintained by Lightman. It started out as a actor model library, but it has spun out into several collection of tools around the actor model.
Hi Ignasi, thank you for the talk. It was
my pleasure.
Pretty good. You said this had some overhead, building the system this way. So how much overhead do you think building a system this way involves, and how would you decide in a new project if this is worth it or not?
Okay, I can reply with an actual real-life case. We have a customer. It's a bank in the US, and they have a system that needs to deliver email notifications every time you get a deposit with your salary, if you are under zero on your balance, blah, blah. They knew that what they had would not scale, as they have just bought some other competitor, and they had to trade off. We lag behind on the notification system, or we pay the price of learning and doing this. The advantage there is that the team they are technically very good. They are pushing us on doing stuff that they will need, but it's like many situations on our industry. It's a trade-off. How much would you lose if you don't pay the cost of this. There is no number. It's a gut feeling. It has to be, right? Friend of mine at the company helped another customer, sorry, go down from 500 nodes to 10 nodes by rewriting the system they had. In particular, they didn't use all these, but only using some of the concepts here, they could do a 50x downsize of their data center needs. That's huge. Not sure if that's the answer you're expecting. I know more or less your problems, and you're not too far from these actually, for what I hear that you guys are doing. So I think you could get some takeaways. We can discuss later if you want. Some more questions? Anyone wants to challenge this? I would be very, very happy.
Hi again. I really like this idea of moving the state from the database to the process.
Mm-hmm.
How do you deal with it, or do you know any techniques when you have lots of, like, let's say, referential integrity in the database, where you have foreign keys all around, and how do you move this to a process? Like, do you program the logic yourself, or?
In our case, the default solution that we are pushing is based on DDD aggregates, and each aggregate is an island of happiness, an island of consistency. Okay, so yes, you will have several problems there. For instance, I think it's called the set problem. It's a set problem involving how can I check that when I'm creating this user doesn't exist. I would have to go to the projection, check the whole table of usernames, and then go back and create it, but then I have a risk condition here. There are some problems, right? And like you said, what if I need to have some foreign keys between two users? I would not be able to grant those. Well, it's a trade-off. The reason why we're pushing away the foreign keys, it's also because it's introducing scalability constraint, right? And we want to go as big as possible. Just an side note. Eduardo, you earlier talked about high throughput. This is not too focused, and I forgot to mention that. This can be high throughput, but it's not so much focused on high throughput as it is on high load. Okay. Ideally, it's both, of course, but in my opinion, high load at this point should be the driver, and well, resilience too. Scalability in terms of load and resilience are the drivers, in my opinion.
Okay, thank you.
If there's no more questions, I think we're all in for a treat, some sugar and caffeine. I'll be around, so feel free to just grab me by the neck. Thanks, everyone.